Okay, everybody, if you would turn to page 14, and I'd like you to look at number 13, and like I have been doing, I would like you to just change your f of x. I know currently it says x cubed plus 3x squared minus 9x plus 1. Cross that one out, and write this one in its place. Okay, so take a second and do that. Page 14, number 13. All right, so what I want you to do is just take a minute, and would you take the derivative of this function? Just take the derivative. You don't need to do anything else. So pause me and do that. All right, so if you look at what I did quotient rule. So low, d high, minus high, d low, over low squared. And then I just distributed everything through here. So when I distributed over here, I got 2x cubed minus 18x, and over here, I got minus 2x cubed. All right, and then from there, I have a 2x cubed and a negative 2x cubed, so those cancel out. So I'm just left with negative 18x over x squared minus 9, that quantity squared. Now remember what we did yesterday. So yesterday we determined critical points on a sign chart based upon three things. 1, endpoints of an interval. 2, where the derivative equals 0, and where the derivative is undefined. Now, the derivative is going to equal 0 where the numerator is equal to 0, and the derivative is going to be undefined where the denominator of the derivative is equal to 0. Okay, so let's go through this. So I'm going to try to do a sign chart now, okay, for f prime. So I'm going to go like this. Now, remember, I have critical points on my sign chart at negative 5 and 5 because those are endpoints of the interval. All right, the next point that I'm going to put on there, and it doesn't matter what order you go in, but I'm going to determine where my derivative is equal to 0, aka where is this numerator going to be equal to 0. And that would be if I put a 0 in here, my whole numerator is 0. Okay, so 0 it is. So I'm going to put 0 down as a critical point. All right, and then the last part that we have to look at is where the denominator of the derivative would be equal to 0. And you should see that if I put a 3 in here or a negative 3, that whole denominator will be equal to 0. Okay, so I'm going to tack on a negative 3 here and a positive 3 here. Okay, so what I'm going to want you to do now is I want you to plug in values in between here. Plug them into this part of the derivative because it'll be easier, and get your signs. Okay, so why don't you take a second, work on that, pause me, go. Okay, so these are the signs that you should have gotten. Plus, plus, minus, minus, and this is for f prime. Make sure, please, that when you are doing your sign chart that you label it with f prime. And now what I'm going to do, just so it can stay on the same screen, is we're going to write the answers for A, B, C, and D. Okay? All right, so A first asks for where it's increasing. So it's increasing from negative 5 to 0. Okay? Now it's increasing from negative 5 to 0 because the derivative is positive during that interval. That's what you should write for the full sentence. I'm not going to write the full sentence. It'll take me way too long to write it on an iPad. Okay, so let's look at part B. When is the function decreasing? Well, that would be from 0 to 5. And that is because the derivative is negative during this interval. Okay, again, you should be writing the full sentence, so make sure that you get that down. All right, part C wants to know where we have maximums. Okay, so I have a maximum here at x equals 0, and that's because the derivative changes from positive to negative, right? Now, there's no sign change here, so that's not going to be a maximum or a minimum. And there's no sign change here either, see? Okay, so that's not going to be a maximum or a minimum either. But here you have a maximum. So basically what your function is doing, watch my green arrow, your function's increasing, 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 increasing till it gets here. Then it starts decreasing, 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 decreasing. So watch again. I start down, I'm accentuating that word for a reason, and then I'm going up, 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 And now I'm going down, 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 which means these endpoints are minimums, okay? Because I'm starting low, going high, then going low again. So -5 and +5 are minimums. So then I am going to write min here and min here. And I know that's a little bit different, but they are minimums. Okay, so then let's look at part C. So it wants to know when we have a maximum. Okay, so hopefully you got that one down. Okay, we've got a maximum at, oops, can't write, at x equals 0. Okay, and for the obvious reason, the derivative changes from positive to negative about that point. Okay, but I want to focus on part D because that's a little bit different. So first we're going to start with a min at x equals -5. Now, we did discuss this yesterday, so I'm going to repeat it again. You have a minimum at x equals -5 because your function after this point is increasing, which makes this a minimum. It's starting lower than everything that's coming after it. Okay? So what you're going to say is there's a min at x equals -5 because the function is, I'm going to abbreviate, increasing after that point. Okay, so there's your sentence for the minimum at x equals -5. Now, unfortunately, you have to write another sentence for x equals +5 because the explanation there is going to be a little bit different. So we have a minimum at x equals +5, and now let's go back and look at that. Okay, so remember, our function, I'm going to start over here, is increasing till we get to here, and now it starts decreasing. So the reason why 5 is a minimum is because before that point, your function is decreasing. Okay? Because f is decreasing before that point. Okay, so there's your reason for that. Okay, make sure you get all this written down in your notes. So now, what I'm going to ask you to do is you're going to pause me in a second, and what I want you to do is, here's your first derivative. Okay, I want you to take the second derivative of that, and yes, you're going to have to simplify it. That's going to take you a little bit. Okay, check with the person around you when you're done to just make sure you guys kind of have the same thing. Okay, so again, I just want you to take the second derivative, so the derivative of this. Okay, so pause me and do that. All right, so this was a bit tricky, I think. I don't think you should have had too much trouble kind of setting up this. So I did low d high minus high d low, just be a little careful on that one, over low squared. Okay, now I want to kind of explain to you how I got from this step to this step right here. So just watch before you write anything down, okay? I looked at the fact that I have 3 terms in this derivative. Look, I have this one before the minus sign, I have this one after the minus sign, and then I have the denominator. And I noticed all 3 of those had an x squared minus 9 in it. Look, this has 2 of them, this has 1, and this has 4 of them. So I canceled out an x squared minus 9. Okay, so watch. So I took 1 out of here, 1 out of here, and 1 out of here. Now if I do that, obviously that still leaves me with 1 here. That's what this is. 1 factor of that left, along with the -18. Okay, now over here on the right-hand side, this disappears completely. So what I did was I have a negative times a negative. That's how I got this positive. And then I did 18 times 2 times 2. I got 72, and then the x times the x is x squared. Okay, and then this becomes x squared minus 9, that quantity cubed, because I took 1 away from here as well. All right, then all I did here was I distributed this through, so this gave me -18x squared, plus that 72x squared, I got 54x squared. And then I multiplied these two guys, and I got a positive 162. Okay, and then I just brought the denominator along. Pause me at any point in time or rewind, whatever you need to do to make sure that you get this. Write this down in your notes. Then here in the numerator, I saw that it had a factor of 54. You don't have to do it, but it makes it a little bit easier to see. And here we go. So here's our second derivative. And this is why I kind of wanted to go over this with you, because I think for you to do this on your own is a little insane. Okay, now we're at the point where we're going to do a sign chart, right? Okay, so if we're going to do a sign chart, remember again, here, let me just throw this right down here. Okay, I'm doing a sign chart for the second derivative. We have endpoints, so we're going to have -5 and 5. And we need to figure out where the numerator equals 0 and where the denominator equals 0. Well, I hope, let's do the easy one first, right here. I hope you see that if I put a +3 or a -3 in here, that denominator is going to be equal to 0. So let's throw those guys on there. -3, +3. Okay, here's the problem with this one. Come up with a number that you can put in here so that when you add 3 to it, you're going to get 0. Think about that. It's not going to happen. There isn't anything. Like, what number could I possibly square and make it negative? Because this really has to be a -3 to add to 3 to get 0. So this will never equal 0, which, guess what? It makes our life easier. There are our critical points for the second derivative. So we don't need to worry about it, because it's impossible to find a number that we can square and get a -3 here so that when we add 3, we would get 0. Okay? All right, so now I want you to pause me, take a minute, and do your signs down here, and then we'll catch up in a second. All right, so here are my signs. And then I went ahead and I answered E, F, and G. So points of inflection are just where you have sign changes. Okay, I didn't write the sentence, but my points of inflection would be x equals -3 and +3. And just because the second derivative, make sure you write second derivative, changes sign about these points. You don't have to say that it changes from positive negative or negative to positive. That's not necessary. Okay? All right, concave up is obviously where the second derivative is positive. So here, because that's where the second derivative is positive. And concave down is from -3 to 3, because the second derivative is negative during that interval. Okay? All right, so I know that one is definitely a little bit tricky, but no big deal on that. Okay, please make sure that you have your notes and that you put all of this in your notes packet, okay? All right, what I'm going to have you do right now then for homework is you're going to work on pages 17 and 18 in your notes packet, okay? Shouldn't take you too long to do page 17 and 18. You're going to do just up to number 3, okay? So page 18 has numbers 3 and 4. You're just doing up to number 3. So number 1, 2, and 3, that's it. Please don't forget your Delta Math bonus for the next test is due next Thursday, I believe. And also, optional exam, again, just re-Google Classroom. All of this is on Google Classroom. It's going to be held at X time on April 5th. Okay? So make sure that you study from your Unit 9, 10, and 11 tests, really, is what you should probably look at. All right, have a good one.